This video is going to review systems of linear equations. When you solve systems of linear equations, you can do it of one of three methods. One method is graphing, another method is substitution, and a third method is using elimination. So in this video, we're going to review all three methods. But before we get to the methods, we need to go through a little bit how you describe the solutions to these systems. So in the example on the left, you can have one solution. That means the two lines cross exactly at one position. And if the lines cross exactly once, that would be consistent and independent. Independent because you have two separate lines that cross at exactly one spot. So consistent means they cross. Independent, you have two separate lines that cross. A second example is you have two lines that are parallel. If the lines are parallel, that means their slopes are the same. And if their slopes are the same, they're never going to cross. So we would consider those or classify those examples as inconsistent. They don't have a solution, therefore they will never cross. And our third example is you will have lines that cross. They have the same exact slope and they have the same exact y-intercept. So they're going to be the exact same line. We would consider this consistent and dependent. So dependent, think they are the exact same line. So infinitely many solutions just means every single number you put in for x and y will be a solution on that line. So let's take a look at our first way of solving a system. So this one we're going to solve by graphing. So we have 2y equaling 6x minus 14. So to solve this one, I'm going to get y by itself. So I'm going to rewrite this. So 2y equals 6x minus 14. So if I get y by itself, I'm going to divide everything by 2. And then graph this one. I would have y equaling 3x minus 7. Now to graph it, I'm going to start with my y-intercept, which is at negative 7. I have a slope of a positive 3, so I go up 3 to the right 1. I can go up 3 more to the right 1, up 3 more to the right 1. The more points you put down, the more accurate of a line you're going to have. And then to draw my line, I'm just going to put my point here. So here's our line. And then our second example, here I'm going to get y by itself. So one way I could do this is I'm going to add y to both sides, which is now 3x equaling 7 plus y. If I subtract 7 on both sides, I now have y equals 3x minus 7, which you'll notice those are the exact same points that I had before. So now if I were to draw my line here, this line would just go all the way through here, which is the exact same line. So we would consider this one consistent and dependent, which means you would have many solutions. Next example, we have y minus 5x is equal to negative 8. So we're going to solve this one by substitution. So in order to solve this by substitution, I'm going to get y by itself in one of the equations. So for this one, I'm going to get y by itself by, I'm going to take this bottom one and divide everything by 3. So if I divide everything by 3, I now have y equals a negative 3x plus 6. So since this is what y equals, I can substitute this in for y of my other equation. So that means I'm going to have negative 3x plus 6, and then it says minus 5x equals a negative 8. Now I'm going to simplify it. Negative 3x minus 5x is a negative 8x plus 16 equals a negative 8. I need to get the negative 8x by itself, so I'm going to subtract 16 on both sides. And I'm left with negative 8x equals a negative 24. And to get x by itself, I'm going to divide everything by negative 8. And I'm left with x equaling a positive 3. So if x is a positive 3, I'm going to use either of the two examples, but I'm going to use the bottom one here because I already have y by itself. I need to solve for y when x is a positive 3. Negative 3 times 3 is negative 9. Negative 9 plus 6 is a negative 3. So y is going to be a negative 3. So my final answer, my solution, it has one solution. So this would be consistent and independent. And my solution is x equaling 3, y equaling negative 3. In our last example, here we're going to use elimination. Now for this one, for elimination, it's best if you have your x and y on the same side. And then you're going to have to eliminate one of the variables. And to do that, you need to have the same coefficient, but with opposite signs. So here, if I look at my two equations, the top one I have 7x plus 2y equals 16. And the bottom one I have negative 21x minus 6y equals 24. Now one of them have positive and the other one has negative. So I'm just going to eliminate the y's. So I look at 2 and I look at negative 6. The common multiple of 2 and 6 would be 6. So I'm going to multiply this top one by 3 because I can make that to a positive 6y. And the bottom one's already a negative 6y, which will eliminate the y's. So I distribute, and that's going to give me 21x plus 6y equals 3 times 16 will give us 48. And when I simplify this, the x's cancel out, the y's cancel off, so I'm left with 0 equaling 24 plus 48 would give us 72. Well, 0 will never equal 72. Therefore, this is no solution, or we can consider this inconsistent. Which just means the two lines are parallel. Now, one way to verify that, if you put both of them into y equals mx plus b, so if I did this one, I would subtract 7x, and you get 2y equals a negative 7x plus 16 divided by 2. I would have y equals a negative 7/2 x plus 8. And if I did the other one, so negative 21x minus 6y equals 24, I added 21 to both sides, you would get negative 6y equals 21x plus 24. Divide by negative 6. I would have y equaling a negative 7/2 x plus 4. The slopes are the same, So because the slopes are the same and the y-intercepts are different, I know the lines are parallel, it means they never cross, and I would have no solution. So that is how you can solve a system of linear equations by graphing, using the substitution method, and using elimination.